Hi, welcome to Lesson 7 in Unit 11 of Algebra 2. Today we're going to look at two very special parent functions, and we're going to discuss their asymptotes, their domain, and their range. We're going to start with the reciprocal function. F of x equals 1 over x. We're going to model it with a table and a graph. So if I plug in 1 over 8th for x, then the y value is 1 over 1 over 8. 1 over something just flips the fraction. Why we call it the reciprocal function. It just makes that 8. 1 over a fraction flips a fraction. So 1 over 1 over 4 is 4. And 1 over 1 over 2 is 2. And 1 over 1 is 1. 1 over 2 is 1 half. 1 over 4 is 1 fourth. 1 over 8 is 1 eighth. And the same is true for the negatives. Negative 8, negative 4, negative 2, negative 1, negative 1 half, negative 1 fourth, negative 1 eighth. So plotting these values gives me, let's see here, 1 eighth goes to 8. 1 fourth would go to 4. 1 half to 2. 1 1. 2 to a half. 4 to a fourth. And 8 to 1 eighth. So we get this famous hyperbola branch here. I say branch because there's going to be another one over here that together makes the hyperbola shape. So negative 1 eighth goes to negative 8. Negative fourth to negative 4. Negative a half to negative 2. Negative 1 to negative 1. Negative 2 to a half. Negative 4 to a fourth. Negative 8 to an eighth. So it approaches very quickly to the axes. All right, we can see that there are two asymptotes. We have a vertical asymptote where the graph rushes towards it from the right and the left, but turns steeply upwards as we come from the right and steeply downwards from the left. We also have a horizontal asymptote. The vertical asymptote is the y-axis, but like all vertical lines, it has an equation x equals 0. And the horizontal asymptote is the x-axis, but like all horizontal lines, has an equation of y equals a number, in this case y equals 0. So my horizontal asymptote is y equals 0. My vertical asymptote is x equals 0. Now, since we cannot divide by 0, I have to remove 0 from my domain. So it's all real numbers except 0. And you can see that 0 does not appear in this graph. And the range is all real except 0. Because the only way you can get 0 for a value when you divide is if you have 0 in the numerator. And my numerator is only a 1. Okay, next we'll consider a similar but just slightly different graph. Y equals 1 over x squared. Okay, so for y equals, or f of x equals 1 over x squared, we're going to be squaring this fraction and then flipping it. So we square the 1/3 to get 1/9, then flip it to get 9. So things are just going to move a little faster on this one. 1 half squared is 1 fourth. When I flip it, I get 4. 1 squared is 1, so that's still going to be 1 1. 2 squared is 4, so it goes to 1 fourth. 3 squared is 9, so that goes to 1 ninth. So 1/3 on the x is at 9. 1 half is at 4. 1 1, and then 2 goes to a fourth, and then 3 goes to a ninth. So what we have is this kind of quicker ascent from the 1 1, and then a quicker descent to the horizontal asymptote. But since when I plug this in, I have to plug it in parentheses, 1 over negative 1/3 squared, it's going to end up becoming 9, because that's 1/9, and 1 over 1/9 is 9. So these values actually all repeat. So we have a graph that's symmetric across the y-axis. We have a horizontal asymptote of y equals 0, a vertical asymptote of x equals 0. The domain is still all real except 0. But our range is now y is strictly greater than 0. Or if you prefer, you could write it in rotation interval notation, 0 to infinity. So the most obvious difference between the two graphs, I mean, there's a slight difference in the shape and the rate that they go up, but the most obvious difference is that the 1 over x squared function, both sides are positive, both sides shoot upwards as you approach x equals 0. Whereas in the previous graph, if you recall, one branch went down. All right, so let's look at graphing with our basic transformations. So we know that 1 over x minus 3, the vertical asymptote is the easiest thing for us to use to create the graph. Let's shift the vertical asymptote from x equals 0 to x equals 3, because this is on an inside, and the insiders will move it left and right. And then I'm not going to worry too much about getting point perfect graphing here. I'm just going to put the point there, and then kind of go with the trends. Remember that the horizontal asymptote was y equals 0. We didn't move up and down, so that didn't change. So y equals 0. The vertical asymptote did shift to the right 3, so our domain is all real numbers except 3. Because if I plug in 3 to the equation, I would end up dividing 1 by 0, which is not allowed. And this is all real except 0. Okay, this is going to move my graph to the left 4 because insiders lie. And so our graph is going to be shaped like this on the right. And you recall that when the denominator is squared like that, both branches go up. Horizontal asymptote of y equals 0. Vertical asymptote at x equals negative 4. Domain is all real except negative 4. And my range is 0 to infinity. All right, for letter C, we could plot some points if we wanted to be really exact. One key difference is instead of going through 1, 1, this kind of turning point will be at 2, 2 and negative 2, 2. But what I really want you to just think about is that 4 just kind of pulls the graph outward. It's a vertical expansion, but it also works to just pull this kind of angle here, pulling it outward like that. But otherwise does not make a change, which is really the most important thing to realize, is that the asymptotes do not change. All real except 0, and all real except 0. All right, on this next one, the negative will flip the branches, so they were like that. They're going to be like that. And because the plus 3 is on the outside, it's going to shift up. We're not going to move the vertical asymptote, but we'll move the horizontal up 3. And we're going to flip the branches. So now the left side is the one on top, and the right side is the one below. Horizontal asymptote is y equals 3. Vertical is x equals 0. We have all real except 0, and the range is all real except 3. All right, time for you to do some practice problems. Pause the video and give it a try. All right, let's see how you did. Shift this one to the right and make both sides go up. Horizontal asymptote, y equals 0. Vertical is x equals 1. Domain is all real except for 1. And the range is y is strictly greater than 0, or 0 to infinity. On this one, we got a couple transformations. We're going to move our graph to the left 2, so the vertical asymptote moves left 2. We're also going to move down 3, so my horizontal asymptote will go down to negative 3. But everything else about the shape will be the same, so I just construct the same kind of image going through that little one away corner there. Like so. Horizontal asymptote is y equals negative 3. Vertical asymptote is x equals negative 2. My domain is all real except negative 2, and my range is all real except negative 3. Okay, this next graph, we are going to have that pull outwards because of the 8, but also it's going to be flipped over the x-axis. You may have plugged in a couple points. If you plug in 2, you'll get negative 4. 4, you get negative 2. So we have kind of this bowed outward shape there. So, but all you're really looking for is to have that flip of position and a slight pull outward. Horizontal and vertical asymptotes do not change. All right, on this next one, we're going to have our reciprocal squared functions shifted 5 to the right, not shifted up at all. So it's going to go like that on this side and like that on the other side. Horizontal asymptote is y equals 0. Vertical is x equals 5. The domain is all real except 5, and the range is all real except, oh, it's not. Sorry, it's y is greater than 0. All right, let's talk about the domain of some more complicated functions. We've done this before, but recall that we cannot divide by 0. So if I have a function that has division in it like this, the domain, I need to remove any x values that result in me dividing by 0. So I simply solve for when the denominator equals 0. My domain will be all real numbers except for what makes this 0. So factor and solve. So my domain is all real numbers except 6 and -1. Let's take a look at a graph. I'll just graph it on a calculator here. All right, and let's see if we do a standard zoom to start with, see if that looks okay. So we should see a vertical asymptote at -1, and we should see another vertical asymptote at +6, where the domain is restricted. You can see that here at 6 and there at -1. Let's try the next one. Again, I can't divide by 0, so whatever makes 4 minus x squared equal to 0 needs to be removed. So that's x equals 2 and x equals -2. So my domain is all real except 2 and -2. Remember, that's the purpose. We're finding the domain, which is extremely important to know the domain of your function for many reasons. Let's take a look at the graph. All right, we should see vertical asymptote at -2 and another one at +2. Okay. All right, on this one here, I need to see if x squared plus 4 could ever equal 0. But it turns out it does not equal 0 for any real number because I end up getting 2i and -2i. So my domain is all real. And we can see that in the graph because we're not going to have any breaks in it. It's not going to be very big. It's going to be hugging this x-axis pretty hard, and then it comes up just a little bit there. You can kind of see it. If I change my window to make my y max into like a 1, we'll get a little bit more of the shape. Wow, that's not much better. Hold on. And let's make the y min 0. That's going to stretch it out. So we might see a little bit more behavior here. There it is. Okay, so I want you to practice doing that same thing. We got A, B, and C for you to find the domain. All right, let's see what we got. All right, you should have factored this one. And I think we need to just do 2x minus 3 and x plus 1, because that would give me 2x squared plus 2x minus 3x negative x. Okay, so solving those equal to 0 gives me 3 halves and -1. So we're going to say all real numbers except 3 over 2 and -1. On the next one, my domain, I cannot allow 81 minus x squared to equal 0, but that factors as 9 minus x, and 9 plus x equals 0. So 9 and -9. So all real numbers except 9 and -9. All right, and on the last one, is there any division? No, there's not. So there's no problem. Remember, the only things we're looking for is even roots of negatives, log of 0 or negatives, and dividing by 0. So none of those things can happen, so my domain is all real numbers. And that is it for this lesson.